Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at log laws and equations. So the 4 laws you need to know are here. You've already seen number 4. This is the change of base formula. We used this when we needed to put logs of a different base into our calculator. The first 3 are just sort of inverses, if you like, of index laws. So you know when you multiply the bases, you add the indices. Well, for logs, it turns out if you add the logs, you multiply their powers, here B and C. Notice for these log laws, we need to have the same base. So add the logs, you multiply their powers. Similarly, when you divide bases, you subtract the indices, and the log is sort of the opposite of that. When you subtract logs of the same base, you divide their indices or powers. And this third law is analogous to the power of a power rule. So if you have log, base, power, and a second power, you can simply move that second power to the front. All right, let's look at some examples where we'll use these to simplify. So log 6 of 9 plus log 6 of 4. Both of these are irrational numbers, but we can simplify this using the first log law. And it says if you're adding logs of the same base, you keep the same base and you multiply the numbers 9 and 4 here. So I get log 6 of 36. So that's just saying, what do you raise 6 to get 36? Well, that's just 2. All right, let's simplify this one here. So there's no log law when you're dividing logs. However, I can use the third rule here. So I can simplify the top. It's got a second power, so I simply move that to the front. And then I can do something similar on the bottom. I can move the second power to the front. I get log x of y times 3. Now these things here are being multiplied. They can be cancelled out and you're just left with 7 over 3. All right, let's try this one here. Log 5 of 500 divide log 5 of 4. So this is kind of like what we have in our change of base formula. We're sort of going the other way. Because we have the same base here, 5, B is like our 500 and A is like our 4. So we can write that as a single log. It'll be log the bottom number, the base, and 500 the power. All right, let's now look at simplifying a slightly harder problem. So let's look at this problem here. Log A7 is y, log A5 equals z. I'm going to write log A of 1225 in terms of y and z. So I need to write 1225 in terms of like 7s and 5s. So it turns out that 1225, you can factorize it as 49 times 25. And of course, 49 is 7 squared, 25 is 5 squared. I can rewrite this as log base A of 7 squared times 5 squared. So how can I simplify this? Well, I have a product here, so I can use that first log law. So the log of the product is the sum of the logs. I can write this as log A of 7 squared plus log A of 5 squared. But using the third log law, if we have a second power, it can simply be moved to the front. So this just becomes 2 log A of 7 plus 2 log A of 5. Now log A of 7, we were told in the question is y, so this will be 2y, and log A of 5 is z. So it's just 2y plus 2z. All right, let's now look at logarithmic equations. So here we have an equation involving logs. So how can I simplify this? Well, because I have one log subtract another, I can combine this into one log. So when using these log laws, I keep the same base, and it will be first power over second power. And that just equals a half. Okay, so how do I solve this? Well, we know that log base 4 is the inverse of raising 4 to the power of something. Essentially what I'm going to do is raise 4 to the power of each side, because 4 to the power of log 4 just cancels out. So what I'm left with is x minus 11 over x minus 14 equals 4 to the power of a half, and 4 to the power of a half, square root of 4 is 2. How do I solve this? Well, I need to get rid of the bottom of the fraction, so I'm going to times each side by that denominator. So I get x minus 11 equals 2 lots of x minus 14. 2 by x, 2 by negative 14. All right, what do I do now? Well, I need to get the x's on one side, so I'm going to subtract x from both sides. And then I'm going to add 28 to both sides. So we end up getting x equals 17. So log base 4 of 6 minus log base 4 of 3 is equal to log base 4 of 2, which is a half. So when you get an answer like this, make sure you check it by substitution to make sure it's correct. If we got an answer like x equals 9, for example, we can't have log 4 of a negative. So make sure you always check. All right, let's do one more example of a logarithmic equation. So this one is a quadratic equation involving logs. So we're going to use a similar trick to when we solved quadratic equations involving exponentials. What we're going to do is we're going to let y equal log base 3 of x. So we get y squared, that's this first thing. Now notice that this here, using the log law, is 2 log 3 of x. So it's actually just 2y, or negative 2y. So now we've reduced this into a quadratic that looks like the ones we know how to solve. So factorizing this, we need two numbers that multiply to negative 3 and add to negative 2. Well, they are negative 3 and positive 1. So we have either y equals 3 or y equals negative 1. But we're not done there. We need to actually solve for x. So we need to substitute back. So if y equals 3, that means log 3 of x equals 3. If y equals minus 1, it means log 3 of x equals minus 1. So how do we undo that? Well, remember, we undo log base 3 of raising 3 to the power. So here, x will be 3 to the power of 3, which is equal to 27. And in the second one, we have log base 3. We undo by raising 3 to the power. So x will be 3 to the power of negative 1, which is a third, and we're done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.